Hello everyone. Here the question is three 60 watts, okay, 120 volts light bulbs are connected across a 120 volt power supply. If the resistance of each bulb does not change with current, then the total power delivered to the three bulbs is going to be. So total power which is going to deliver to the three bulb we have to find this. Okay. First, according to the question, I am going to draw. So the bulb which is present right here, where the mouse point is exactly present, okay, is going to be this. Okay, this is the resistance of this bulb and resistance of this bulb. Also, the resistance of this bulb. Okay, I'm going to draw a straight line. So this is the points, 2 points. Okay, as per this diagram has been drawn right here. Okay, now let's next thing what we are going to see here is, okay, so the power is going to be, the power of this thing is going to be 60 watts. 60 watts. 60 watts. This is power actually. Power. The relation between the power and the resistance is going to be, this is power. Power is going to be equal to work done by work done by time. Okay, so we everyone knows this. Okay, work done is nothing but force into displacement. So here the work done is going to be charge q is a charge. Okay, q into the potential difference. So we are going to substitute this thing right here. So q by this t is a time, okay, into v. Okay, normally we know that q by t, so charge per unit time, okay, crossing an unit area is called current, which is equal to iv. Nothing but the power. Power can be written as I is the current, v is the potential difference. Okay, now normally we have to write in the terms of, so according to the Ohm's law, V is equal to IR, right? V is equal to IR. So I can be written as V by R. So this I can be written as V by R. Okay, I can be written as V by R. So V by R into this V, and the power is equal to V square by R. Right? Power can be written as V square by R. The power is going to equal to V square by R. Then what that resistance can be written as? The resistance. Okay. The resistance can be written, the total resistance. We have to find the total resistance right here. So this is the concept. Just I be erasing these things, the other things. Okay, the concept which we are going to use right here is nothing but P is equal to the power exhibited is going to be equal to the total potential difference provided, okay, divided by the resultant resistance. Okay, now let us consider this resistance. The resistance of this is going to be R, and this is going to be R, this is going to be R. Since the power is going to be the power of this three resistor is going to be same, so we are going to use as R. Definitely it is going to be R. Okay, since the power is going to be same, the voltage is going to, so the resistance is also going to be same. Okay, now using this we are going to solve this. Okay, so this both are in parallel. So whenever resistance in parallel is equal to R1 R2 by R1 plus R2. This is the formula for resistor in parallel. It is nothing but the 1 by Rp, the resistance parallel can be written as 1 by Rp, which is equal to 1 by R1, 1 by R1 plus 1 by R2, 1 by R2. So this equation can be also written as like this. So by cross multiplication, nothing but by cross multiplication, okay. I am just doing the same thing, okay. So Rp, okay, is nothing but this equation is written like this, okay. Now cross multiplication, R2 plus R1 by R1 R2. Or so since my mouse point is not working properly, I cannot able to write it a perfect manner, okay. So this is in this inverse, this can be written as like this. Understood? So I think everyone can understand what I'm trying to say right here. Okay, now we have to find the resultant resistance for this blue color, okay, which I drawn in the blue color. So I am going to find this resistance. So there is nothing but R1 and R2 is going to be same. So R square by 2R, so R by 2. So this both the terms gives the R by 2 value. Now this both the terms I'm just changing the color. So this both the terms is going to be in series. Whenever the resistor in series is going to equal to R1 plus R2, R1 plus R2. Okay, so right here R1 is R, R2 is R by 2, R by 2 right here. So we are going to find the resultant resistance, okay, the equivalent resistance, the final resistance, okay, nothing but, okay, which can be written as, so LCM 2R plus R3 by 2, 3 by 2, R is the total resistance, the resultant resistance for this equation. Now, next we can able to move for the next step. So we are going to use this formula right now. So the resistance, the equivalent resistance for this thing is 3R by 2. So we are going to substitute the thing. So power P is equal to V square by this R. R is nothing but 3 by 2, 3 by 2, 3R by 2, which can be written as V square, okay, V square by V square into, okay, V square by 1 into 2 by 3R. When it comes to the numerator, it is going to be becomes as inverse. So this both the value when come to the numerator, it becomes inverse, right? Okay, whether you guys can understand, I think, okay. So now, so what is the value given, the potential difference given to this is going to be 120 120 volt is going to be the potential difference between them. So 120 into 120, 120 into 120 into 2 by 3 into R. So we have to find the individual power. So individual power is given as, so R individual R. So individual power is given as 60 watts. I'm just moving to the next page for this. So 60 watts is the given power for each the bulb. One bulb is 60 watts. So voltage is going to be the resistance. So resistance is equal to voltage given square by 60 is known as the resistance of single. R is R value is going to be the resistance of a single resistor, single bulb. The resistance of the single bulb is going to be, so sorry, each and everything, every bulb consists of 120 volts, 120 voltage. So 120 square, right? 120 into 120 by 60. By cancelling this, 240. right? 240. So each resistance, the resistance of a single bulb is going to be 240. Okay, instead of this R, I'm going to write 240. Just 240. Okay, this is going to be get cancelled, and this is going to be get cancelled by 2, and this 2 get cancelled, and this is going to be get cancelled by 40. Finally, the resultant power is going to be the resultant power, which implies the resultant power is going to be 40 watt. 40 watts, that is option 3 is the correct answer for this question. Thank you.